Okay, so we're going to find the zeros of this polynomial and several others. So we can solve this one in two different ways. 48 factors into 2 and 24, but that doesn't add up to 8. It factors into 4 and 12, which, what do you know? If this is minus and this is plus, that equals 8. So this polynomial factors into x squared minus 4 and x squared plus 12. And so to find the zeros, we set it equal to 0, and we take each factor, so these are called factors, and solve each factor for x. So when I take the square root of both sides here, remember you have to do plus or minus, so this is plus or minus 2. And then we have the other factor, x squared plus 12 equals 0. Subtract the 12 from both sides, and we see what's going to happen is I'm going to take the square root of a negative. Whoops. So I'm at x squared equals minus 12. So I'm going to take the square root of both sides. So this becomes plus or minus I times the square root of 12. So it happens when you take the square root of a negative number. There's a video on complex numbers and square roots. And then we can simplify that 12. So 12 is the square root of 4 times the square root of 3. And we can write that a lot of different ways. Plus or minus 2i square root of 3, or 2 square root of 3i. All are correct. So I take that back, and here's 2 zeros. So this is a 4th degree polynomial. There should be 4 zeros. And those 4 zeros are 2 minus 2, 2 square root of 3i, and minus 2 square root of 3i. So if I were to write that as a set, I would put, this would be the solution set. And so my math lab would probably already have these brackets there, and then you would just type in 2 minus 2, 2 square root of 3i, and minus 2 square root of 3i. Make sure that the I is outside of that square root. All right, next problem. So this one, oh wait. I wanted to show you another way to do it. So if you did not realize that you could factor that, and you wanted to do it the way we've done all the others, what we would do is we would begin by graphing this. Whoops. So we would go to there. And we would graph x to the 4th plus 8x squared minus 48. Okay, I can graph it. I don't remember the last thing I did, so we're going to go zoom standard. I think that's zoom standard. And we see 2 zeros right here. Let's go to the table to figure out a little bit more. Okay, so there's negative 2. Negative 2 is a 0. And 2 is a 0. So those are the 2 that we saw. So let's go back. and we know that x equals 2 is a 0, and x equals minus 2. So we have 2 and minus 2. We can write it like that. Now how would we have gotten x equals plus or minus 2? We would have taken x squared equals 4. So we can, if we recognize that x squared, or if we have the factors plus 2 and minus 2, we have the x squared minus 4 as a factor. Okay, and then I can take this x squared minus 4 and divide it into x to the 4th plus 8x squared minus 48. Okay, now we have to be careful here. So that's an x squared. So x squared times x squared minus 4 is x to the 4th minus 4x squared. So we distribute and we subtract. So we get 8 minus a minus 4, that's 12. And so I do 12. And distribute that. Subtract, I get 0. And so there's my factor. I'm going to go back. And so I have this factors into x squared minus 4 and x squared plus 12. So I've already gotten the zeros from here. So I need to take care of the zeros from here. And at this point, everything is the same as it was on the other one. All right. There we go. And so the solution set is 2 minus 2, 2 square root of 3i, and minus 2 square root of 3i. Okay, and I want to do this one more way. So we have y equals x to the 4th plus 8x squared minus 48, and we found that 2 was a 0 and minus 2 was a 0. So I have factors of x plus 2 and factor x minus 2. This goes with that one, and that one goes with that one. Okay, so each one of these are factors. So I can take this and divide this polynomial by the individual factors. Probably don't have enough room to put that there. So we'll do this division twice. So let me show you how this is going to work. So x, that's going to be x cubed times that. It's going to give us x to the 4th plus 2x cubed. And we subtract. Now there's no x cubed term up here. So this cancels. There's no x cubed term, so we get minus, so we get 0x cubed minus 2x cubed. And now I'm going to divide this in here, so I'm going to get minus 2x squared So minus 2x squared times minus 4x squared. Okay, so this time the polynomials line up, so this is going to give me, so that cancels, and I get 8, oh, whoops, that's a minus. 8 minus a minus 4 is plus 12. Okay, I'm going to bring down the 48. That's going to go in 12x times. So I get 12x squared plus 24x. I have to pay attention again because there's no x term. So the x squareds cancel, and I get 0x minus 24x. And we can see here I'm going to get minus 24. And that gives me a remainder 0. Okay, so I've done it one time. That doesn't look a whole lot better. You might be able to do factor by grouping. I mean, you can do factor by grouping, but we can take this polynomial, minus 2x squared what is it, plus 12x minus 24. And divide it by the other factor. So we divided, remember there were two factors, x plus 2 and x minus 2. So I divided by x plus 2, and now I'm going to divide by the other factor. So I'm going to take this and divide it by x plus 2, and I get that number, or that polynomial. I'm going to take the result and divide it by this, so I'm going to get x squared I'm going to pull down the 12x minus 24. I get 12. Oops. So, what that says is that this polynomial factors into x plus 2, x minus 2, x squared plus 12. And then again, this gives me the minus 0, or the minus 2. This gives me plus 2, and this gives me the plus or minus 2 square root of 3i. So there's 3 different ways to get that. So let me do a number analogy. So let's take 48. So if I divide 48 by 2, that gives me 24. And then if I take 24 divided by 2, that gives me 12. So when I have a number that's got different, factors, and the factors are composite, then I can, divide by different, I can take the result and divide by a different factor of the original number, and it'll go in evenly. So that's essentially what we were doing here. We had the 2 zeros. We could have multiplied them together to get one factor of degree 2 and do the division, or find 2 first-degree polynomials and divide one into the original and the second one into the result of that to get the other one. Okay. We're going to find the zeros of this polynomial. Okay, I don't know anything about it, so I'm going to start by looking at its graph. Oops. Okay, so we have to graph that. X cubed x minus 28. Okay, we graph that. All right, and we see a 0 right there. We go to the table, and we look through some of the values in the table, and at 4 we see a 0. So we know that x equals 4 is a 0, which means that x minus 4 is a factor. So I'm going to go to the next page and take x minus 4 divided into x cubed minus 2x squared minus x minus 28. X goes into x cubed, x squared times. That cancels. That gives me 2x squared minus x. So x is going to go into that 2x times. (2x squared minus 8x). And we subtract. So that gives me that x squareds cancel, and I get 7x. Bring down the 28. And x is going to go into that 7 times. And I get 7x minus 28. When I subtract that, I get remainder 0. Okay, so going back, that says that this polynomial factors into x minus 4 and x squared plus 2x plus 7. Okay, so this doesn't really look like it factors. So I'm going to look at this factor. So the other zeros are going to come from the zeros of this factor. Okay, I'm going to do the quadratic formula. So I start off by looking at the determinant, b squared minus 4ac. So there's b, a, b, and c. So b squared is 4 minus 4 times 1 times 7. So I get 4 minus 28, which is negative 24. So I'm going to get complex zeros because I'm going to take the square root of a negative. So continuing on with the quadratic formula, I get minus b plus or minus the square root of the determinant all over 2 times a. So you get minus 2 plus or minus. The minus becomes an I. So this is the square root of 24. I times the square root of 24. 24 factors into a lot of different things, but one of the things is a factor of 4. So just keep working it. The square root of 4 is 2. On top, I can factor out the 2, leaving a minus 1 plus or minus the square root of 6. I'm going to move the I to the back. All over 2. That cancels. And I get x equals minus 1 plus or minus the square root of 6 I. So my solution set is, let me go back and check, 4 minus 1 plus the square root of 6i, and minus 1 minus the square root of 6i. Now we can't use our calculators to check this, really. We can't use the graph, that's for sure. So we just, check our work to make sure everything looks okay, and as far as I can tell, it does. That's what I cooked up the answers to be. All right.